Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single one of these problems. If you're interested in watching the original solutions to these problems, you will find the original solutions from day number 1 through to 50. Right now, we are in the process of redoing the problems, and we are on page number 168. Okay, turn to page number 168. Problem number 116 is what we're about to start. This problem that we see on the blackboard, problem number 116, it says P is the product of integers from 1 through 30. Yes, P represents the product of integer 1 through 30 inclusive. In other words, P equals 1 times 2 times 3 times 4 times 5 all the way up to 30. Question is, what's the greatest integer k? What's the greatest integer k that we can find for which 3 raised to k is going to be a factor of this number P? This problem that you see on the blackboard, problem number 116, is very similar to the problem that we did yesterday on day number 303. If you have not watched yesterday's video, day number 303, I strongly suggest that I strongly recommend that you watch this video first, 303. Watch the simpler version of this question first, understand what's going on in the problem, and then do this problem on your own first before you continue watching this video. So one more time, if you have not watched that video, stop this video immediately, watch that one, understand the problem, do this problem on your own, and then come back and resume watching this video. Do you understand? So here's what's going on. We are told that P is such a number that it represents the product of all the integers from 1 through 30. 1 times 2 times 3 times 4 times 6, 7, 8, 9, 10, all the way up to 29 times 30. This is our P. The question is, what's the greatest integer k that we can find so that 3 raised to k is a factor of P? Is a factor of P means that P can be evenly divided by 3 raised to k. In other words, what we are being told here is that the quantity P can be written as some integers n times 3 raised to k. Our job is to find out the greatest possible value of k. Greatest possible value of k. Obviously, as we can see clearly from here, P can be written as some number n times 3, right here. So if we take away this 3, then n would represent the product of 1 times 2 times 4. Just leave out the 3 and then continue all the way to 30, and this P would be 3 times that, P would be 3 raised to 1 times n, that number there. But that k equals to 1 would not be the greatest value of k. Our job is to find the greatest value of k such that this equation holds. Let's do it, shall we? Enough of the talk, let's just do it. So here we go. So P equals 1 times 2 times 3, which can be written as 3 raised to 1, times 4 times 5 times 6, which can be written as 2 times 3, times 7 times 8 times 9, which can be written as 3 squared, times 10 times 11 times 12. You get the idea. You're getting the idea. That's it. That's your 12. Times 13 times 14 times 15, which can be written as 5 raised to 3, times 16 times 17 times 18. I'm not going to do all of them here. Times 18, which can be written as 18. This is not going to work. I almost made a mistake. Because I was too busy talking. You could write 18 as that. You could represent 18 as 6 times 3. But our job is to find the greatest integer k for which 3 raised to k is a factor of this thing. So instead of writing 6 times 3, what we need to write, we need to represent 18 as 2 times 9, which in turn can be written as 2 times 3 raised to 2. And then you're going to have 19, 10, 20, and then 21. 21 will be 3 times 7. Then you're going to have 20, 22, 23, and 24 will be 8 times 3. That's all you can do there. 8 times 3. Let's put it the consistent way. 3 times 8. That's 24. Then we're going to have 25, 26, and 27. 27 is the next tricky one. 27 could be written as, so this is what we're doing, 16, 18, 16, 17, 18, 19, 20, and then 21 is written as 3 times 7, that's your 21, and then 22 times 23 times 24 is right here, 3 times 8, I wasn't going to do it, but I changed my mind. 24, because sometimes this takes less time just to do it instead of telling that I'm taking a shortcut. 24, then we have 25 times 26 times 27. 27 is what we're discussing here. How can we write 27? Again, 27 can be represented as 3 raised to 3. That's our 27. Then we'll have 28, then 29, and then finally 30, which can be written as 3 times 10. 3 times 10. That's it, we are done. We are done. All we have to do now is to add up all the exponents. So let's do that. Let's add up all the exponents so that we can find the greatest integer k, for which 3 raised to k is going to be a factor of this guy. So here's the first one, 3 raised to 1. Here's another one, 3 raised to 1. That's 2 so far. Okay, I better be quiet because otherwise I'm going to end up making mistakes. 1 plus 2 is 1 plus 1 is 2. 2 plus 2 is 4. Then here's the other one. 4 plus 1 is 5. 6. 7, 8. 7, 8. This is 2. 7, 8. 9. 10. 13. And finally 14. Voila. Voila. That means P can be written as this P right here. This P can be written as some number n times 3 raised to 14. That is the greatest integer k that we can find. That's all it is. That's it, we are done. The question is, what does n equal to? What does n equal to? Can you figure out what n equals to? I can show you up here if you like. As far as the problem is concerned, we are done. The answer is 14. The k equals, the greatest value for k is 14. That's all. Let's find out what n is equal to. I'm going to show you in the top here. In this equation, P is equal to n times 3 raised to 14. 3 raised to 14. In this equation, n would equal, okay, what's here? 1 times 2 times 3, but we took out the 3, didn't we? We took out the 3. 3 has been taken out right here. 3 has been taken out. Then we have 4 times 5 times 6, but 6 we took out the 3, so now we're left with 2. That's our 6. Then 7 times 8 times 9, but we took out the 9. 9 was 3 squared, we took it out. So it's just going to be times 1, times 10, times 11, times 12, which is 3 times 4. Right here is 3 times 4, so that's a 4. Then that's a 12 here, right there 12. Then 13 times 14 times 15, which is going to be 5. 16 times 17 times 18, which is just going to be 2, because it's 2 times 9, we took out the 9 right here, 3 squared. So we are up to 18, then we have 19 times 20 times 21, which is times 7, that's 21, 22, 23, 24 was 8, and then 25, 26, and 27 is just going to be 1, because we took out 27, 3 cubed. So that's 27, 28, 29, and finally 30, which is times 10. This is our n. This quantity right here is our n. But that was not required, that was not asked for. We're just doing it just for learning purposes so that we understand it thoroughly. But that's it, that's the problem. The answer is the greatest value of k that we can find, the greatest exponents of 3 that we can find is 14. P is evenly divisible. In other words, P is evenly divisible by 3 raised to 14. Of course, P is also evenly divisible by 3 raised to 13 and 3 raised to 12 and 3 raised to 10 and everything. But we were looking for the greatest possible integer. Answer is 14. Let's do the next one, shall we? Number 117. In number 117, they're asking us if n is equal to 3 raised to 8, if n is equal, this is 117, if n is equal to 3 raised to 8 minus 2 raised to 8, question is, which is not a factor of this quantity n? Another tricky one. Here are the answer choices. A is 97, A, B, C, D, and E. 97, 65, 35, 13, and 5. And what you will find is that, as I always break into a sermon at a situation like these, what you will find is that these problems are not necessarily necessarily difficult. They do not involve any complicated math. You just have to remain calm. You just have to remain collected and think rationally, logically, calmly, collectedly. Do you understand? If you all get worked up, you're not going to get anywhere. It's not going to get you anywhere. Do you understand? Let's do it together. We need the room, obviously. We're going to have to erase all of this thing. It's all done. It's all gone. I'm not going to go into too much details. As I remind you there, if you need to go at a slower pace, if you need more help, if you need some more details, the original solutions are there from day number 1 through 250. You can find the problem where I have done the same problem at a much slower pace. Here, what we can understand is that this 3 raised to 8 minus 2 raised to 8 actually can be written as 3 raised to 4 squared minus 2 raised to 4 squared. So here we have some quantity being squared minus some other quantity being squared. What we're dealing with is this, a squared minus b squared. And as we know, this formula here, this quantity here is referred to, this quantity is referred to as difference of 2 squares. This formula is called difference of 2 squares. And of course we know that a squared minus b squared equals a plus b times a minus b. Just a second ago I told you I wasn't going to explain anything, and there I go again. I guess it's compulsive, you see. So let's do that. A plus b and a minus b. A is 3 raised to 4 and b is 2 raised to 4. So it's going to be, this quantity is going to be equal to 3 raised to 4 plus 2 raised to 4 minus times 3 raised to 4 minus 2 raised to 4. So far so good? So far so good. This quantity in turn can be written as 3 squared minus 2 squared, right, like that. And that of course can be further broken up into 3 squared plus 2 squared times 3 squared minus 2 squared. Are you with me so far still? And that quantity, the last quantity here, 3 squared minus 2 squared, can be further broken up into 3 plus 2 times 3 minus 2. That's it, we're done. So this entire quantity that we see here is written as, it can be written as 3 squared plus 2 squared times 3 plus 2 times 3 minus 2 times 3 to the 4th plus 2 to the 4th. And that is our quantity that is given to us, n. This is our n. Let's put this n on the top so that we can do something with it. Let's put it up here. We no longer need the problem. So we can put it up here. So our n, we just found out, our n equals to 3 raised to 4 plus 2 raised to 4 times 3 squared plus 2 squared times 3 plus 2 times 3 minus 2. Of course, 3 minus 3, we're just writing it for curiosity here, for theoretical purposes, purely for theoretical purposes, because 3 minus 2 is just 1, obviously. Here are the answer choices. Let's see what it gives us. 3 raised to 4. How much is 3 raised to 4? Do you know? 3 squared is 9, and 9 times 9 is 81. 3 to the 4th is 81. 3 raised to 4 is 81, which is same as 9 squared. 3 raised to 4 is same as 9 squared, which is 81. So here we have 81 plus 2 raised to 4. How much is 2 raised to 4? 2 raised to 4 again is same as 4 squared times 4 squared, which is 16. And then this is 3 squared is 9. 9 plus 4 is the 13. I'm gonna pick up speed. I'm taking too long here. This is 5. Let's add up these two numbers. 81 plus 16. Let's add them up. 81 plus 16. What is 81 plus 16 going to give us? 81 plus 16 is going to give us, what do you know? It is going to give us 97. 97. Let's erase this thing. So n equals to 97. N can be written as 97 times 13 times 5. We are almost there. As you can see, n has been broken up into 3 parts. 97 times 13 times 5. What does it tell you? It tells you that 5. It tells us this will be a good time. This will be a pretty dramatic moment. to change the color, that tells us that 5 is a factor of n. 5 is a factor of n. Voila, 5 is a factor of n. It also tells us that 13 is a factor of n. There you go, voila. It also tells us that 97 is a factor of n. And finally, if 13 is a factor of n, if n can be divided evenly by 13, and if n can be divided evenly by 5, then n must also be divisible by 13 times 5, which is 65. Which means 65 is also a factor of n. The only number out of this 5 which is not a factor of n, that was the question. The question was, which of the following is not the factor of the given quantity n? The answer is 35. I made it so crowded, the answer is 35. 35 is not. This is our answer. Answer is 35. 35 is not a factor. Okay, let's go to the next one. I need a break again. We need the room, obviously, so we're going to have to erase everything. What can we erase here? Here's the next question for you. Now the question is, this is the bonus one. This is not in the book. Here's the question. Which of the following is a factor of 5 raised to 4 minus 3 raised to 4? 5 raised to 4 minus 3 raised to 4. Here are the answer choices: A, B, C, D, E. 13, 15, 17, 19, and 21. And 21. One more time, the quantity that is given to us is 5 raised to 4. 5 raised to 4 minus 3 raised to 4. And the question here is, which of the following, there are 5 quantities that are given to us, obviously, in the 5 answer choices. And here, the question is phrased in just the opposite way. It is the converse that we're looking for. Do you understand? Which of the following is a factor of this quantity, 5 raised to 4 minus 3 raised to 4. In other words, there are 5 quantities here. 4 of them are not the factor of this quantity. There is only one quantity that qualifies as a factor. In other words, this quantity 5 raised to 4 minus 3 raised to 4 can be divided by only one of these 5 numbers. Our job is to locate that number. Again, at this point, what I want you to do is pause the video immediately. If you understood this question, there is no reason why you cannot do this on your own. Pause the video, do the problem. Once you've finished doing it, resume the video and then compare your work against the work that we're going to do together. This is how we learn. Do you understand? Let's go ahead and do it. Let's start the solution now. Let's do it down here. Let's do the problem right down here. It's very simple, same as before. Let's call this quantity, let's give it a name so we can talk about it. This was n, what do you want to call this thing? I'm going to call it A. So A equals 5 raised to 4 minus 3 raised to 4, which in turn can be written as 5 squared plus 3 squared times 5 squared minus 3 squared. This is a very simple problem. You will see it's a very simple problem. And that in turn can be written as 5 plus 3 times 5 minus 3. 5 squared plus 3 squared. And this is our A. A equals 5 squared plus 3 squared times 5 plus 3 times 5 minus 3. Let's find out what these quantities are. 5 squared is 25, 3 squared is 9, 9 plus 25, 25 plus 10 would have been 35, so this is 34. 34 times 8 times 2. 34 times 8 times 2. This doesn't get us anywhere, does it? What do we do next? That doesn't get us anywhere. I don't see 8 here. Which of the following is? I don't see 8, I don't see 2, I don't see... What can we do now? Aha! This 34 can very easily be written as 2 times 17 times 8 times 2. Which means 2 is a factor of A 2 times 4, 8 is a factor of, 2 times 2 is 4, 4 is a factor of A. 4 is not here, 2 is not here, 8 is a factor of A, 8 is not here, but 17 is. Voila. This quantity 5 raised to 4 minus 3 raised to 4 can be evenly divided by 17 because A equals 2 times 17 times 8 times 2. In other words, A is equal to 17 times 2 raised to 5. 2 squared and 2 cubed. This is our A. I'll see you tomorrow, okay? Bye now.